Hello wonderful person, this is Anton, and today we're going to be talking about the finally confirmed neutron star in the middle of the supernova known as 1987A. And this beautiful picture that was recently taken by the scientists behind this paper shows us exactly where the neutron star is located. Let's talk a little bit more about this and why it's important, and welcome to What the Math. So a little bit of history first. This right here is known as the Keplers Supernova. Roughly around 400 years ago, Johannes Kepler was looking into the night skies and noticed something very unusual in the location you're about to see right there in the middle of the night skies. Now this is where he saw a very bright flash, and this was the first ever naked eye observation and analysis of an actual supernova in progress. Today it sort of looks like this. This is the Kepler supernova with the neutron star in the middle of it. And today we believe that this was the most recent supernova to occur in our own galaxy, at least in the last few hundreds of years. There might have been some we haven't actually noticed, but this was the one we could definitely see from planet Earth. And this was at a distance of about 20,000 light years away from us. But the most recent so-called naked eye supernova, or supernova you can see without any support from a telescope, was an event in the nearby Large Magellanic Cloud, and today we refer to it as SN 1987A, because it was first observed in 1987 and this is exactly when it started. And just to give you a better idea, let's try to zoom in to the location where the supernova began by looking at the actual picture from Hubble telescope. So here, as we're zooming in, you'll start seeing the remnant of the supernova, and it's actually really beautiful. Any second now you're going to see it. This is right in the middle of the Large Magellanic Cloud. So somewhere right there, there's that beauty. This is only about 33 years ago from when I'm making this video. And here is an amazing simulation that NASA produced that shows you how the supernova occurred and why it has the peculiar shape that it has today. So in the last few years, this is basically what happened to it and why it has this beautiful ring that we see in the middle. Lastly, here are the actual images taken by Hubble over the years that shows you how the supernova progressed in real time. And this is honestly really mind-blowing. And the thing about this event is that it was extremely mysterious because for practically 33 years now, scientists were thoroughly trying to analyze this event and watched it progress in practically real time, but they were also trying to discover what was left behind after the explosion of the star that was probably about 20 masses of our own sun. And this was also obviously much farther away. The distance here is at least 165,000 light years away from us, so trying to detect a tiny object that was left behind that was probably only a few kilometers across is somewhat challenging. But during this event, the scientists also detected quite a lot of neutrinos coming from this direction, and this meant only one thing, that it wasn't really a black hole that was being created. Because we believe the creation of a black hole would not lead to so many neutrinos being detected. Instead, the scientists always believed that the explosion left behind a neutron star. It could have been a pulsar, it could have been a magnetar, but it was definitely not a black hole. And this is what they've been looking for the past 33 years. Interestingly, pretty much everything about the neutron star was theoretically already predicted. The scientists knew where it should be located, how fast it was moving because of the explosion, and they even estimated the approximate mass and of course size of this neutron star as well. The only problem is that no matter how hard they kept looking, they weren't seeing anything. There was obviously no pulsations coming like from a typical pulsar, and there were no other emissions of any kind. But the most recent detailed observations, specifically from the region near this explosion, revealed this unusual area right there that had this very large and very bright blob of matter that was being displaced and heated up by something roughly around 5 million degrees Kelvin. And this is where the scientists kind of scratched their head and decided to look at theoretical papers. Because whatever this was, it was hotter and more energetic than any neutron star they ever expected to find. It was much hotter than a typical neutron star. And it didn't really take them long to discover that the theory behind neutron star formation does actually suggest that the newly born neutron star is extremely hot and extremely luminous, very bright. As a matter of fact, it takes approximately 2 years for a typically newly created neutron star to drop in luminosity to the point where it becomes a regular neutron star. So when they're just created, they are these extremely luminous and very hot objects. And so the new study allowed the scientists to confirm that this is indeed what they were looking at. They were just looking at the first ever youngest neutron star we've ever seen. Because what we're looking at here is a neutron star that's only about 33 years old. The other previous record holder for the youngest star was this right here, the neutron star known as Swift J1818, discovered last year, and it was about 240 years old. And the one before that was the famous Cassiopeia A, with the Supernova Remnant visible right here, that occurred about 300 years ago. In other words, this is essentially the youngest neutron star we've ever observed, and we just didn't really expect for neutron stars, for young neutron stars, to have such extreme effects. Specifically such extreme temperatures and extreme luminosities. And these new models for neutron star evolution also suggest that it's going to continuously dim for the next decade or so, while at the same time the supernova itself, or the remnant of the supernova that is finally going to slowly dissipate and allow us to see the neutron star in more detail. For now the gas is still hiding it, so this here is unfortunately the best picture we have of this. But once this dust dissipates, in approximately 1 or 2 decades from now, we're going to be able to start observing the neutron star directly and thus study its evolution even more. And other than that, everything else about this discovery and of course the neutron star itself seems to fit perfectly with our predictions. The size of this object is about 25 kilometers across. The surface temperature is about 5 million degrees Kelvin, and most importantly, if you were to look at the location of the blob versus the center of the supernova, this is exactly where the scientists predicted this neutron star to move toward. In other words, even the velocity of this neutron star across the Large Magellanic Cloud galaxy seems to fit with the prediction perfectly. So in the next decade or so, we're going to get even more studies about this object and possibly discover something else incredible about neutron stars that we never knew before. For now, the important part here is that it does seem to fit with the new theories about their formation, and it looks like we now understand their creation and their early life much better as well. All of which you can also discover by reading the study in the description below. But I guess the nutshell of the discovery is that the neutron stars are even more extreme than we originally thought when we just found them. They seem to be the most extreme objects in the universe, possibly even more extreme than the black holes. So learning more about them will help us understand the universe even more. But I guess until we discover more, that's all I wanted to mention in this video. So if you've enjoyed it, don't forget to subscribe, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe consider supporting this channel on Patreon because it does help me quite a lot. And alternatively, you can also support this channel by buying the Wonderful Person t-shirt that I'm also wearing right now as well. I'll see you tomorrow, space out, and as always, bye bye.